Across the vast Pacific Ocean, a silent force is beginning to awaken once again. Invisible to the human eye, yet powerful enough to reshape weather across the entire planet. This is El Niño. Every few years, the balance of the Pacific Ocean changes. Waters that are normally cooler begin warming above average, quietly setting in motion one of Earth's most influential climate patterns. Beneath the surface, enormous amounts of heat build over many months. As this hidden warmth spreads eastward across the equator, the atmosphere responds in ways scientists have studied for decades. The powerful trade winds that normally push warm water toward Asia begin to weaken. Without these steady winds, warm water flows back toward the Americas, altering weather patterns across the globe. What begins as a change in ocean temperature soon becomes much larger. Storms shift their paths, rainfall moves into unexpected regions, while drought tightens its grip elsewhere. Hurricanes, floods, wildfires, and agriculture can all be affected by this single oceanic event. From hundreds of kilometers above Earth, satellites detect ribbons of unusually warm water stretching across the tropical Pacific. At the same time, thousands of floating ocean buoys continuously measure temperature, currents, sea level, and wind, giving scientists an unprecedented view of our changing climate. For millions of people, these changes may seem invisible at first. Yet farmers, fishermen, emergency planners, and entire communities often experience the consequences long before they understand the cause. Around the world, scientists continue watching the Pacific more closely than ever. But what exactly causes El Niño? And why can a warming ocean influence weather across nearly every continent? To answer those questions, we must journey beneath the surface of the world's largest ocean. Under normal conditions, strong trade winds blow steadily from east to west across the tropical Pacific. These winds push warm surface water toward Indonesia and northern Australia, where sea temperatures become some of the warmest on Earth. As warm water accumulates in the western Pacific, colder, nutrient-rich water rises along the west coast of South America through a process known as upwelling. This natural cycle supports one of the richest marine ecosystems on the planet. Together, the winds, ocean currents, and rising cold water create a delicate balance that has shaped Earth's climate for thousands of years. But that balance is surprisingly fragile. Sometimes, for reasons scientists are still working to fully understand, the trade winds weaken, or briefly reverse. Without those winds holding warm water in the western Pacific, billions of tons of stored heat begin flowing back toward the central and eastern Pacific. As warm water spreads eastward, the thermocline, the boundary between warm surface water and the colder ocean below, sinks deeper than normal. Cold water can no longer rise efficiently, allowing the surface to warm even further. The atmosphere reacts quickly. Cloud formation shifts, rainfall patterns change, and the Pacific climate system enters a new phase. This powerful interaction between the ocean and the atmosphere is known as the El Niño Southern Oscillation, or ENSO, one of the most influential climate cycles on Earth. Once El Niño develops, its effects extend far beyond the Pacific, influencing weather across much of the world. Today, the Pacific continues to send new signals. Satellites orbit overhead while thousands of ocean buoys record changes every hour. Powerful supercomputers analyze millions of observations, helping scientists improve climate forecasts. If El Niño conditions strengthen, some regions could experience heavier rainfall and flooding, while others may face prolonged drought, extreme heat, or an increased risk of wildfires. The exact impacts depend on many interacting climate systems, which scientists continue to monitor carefully. Warmer oceans can also affect marine ecosystems. Reduced upwelling limits the nutrients reaching the surface, influencing fish populations and the communities that depend on them. Across the globe, governments, emergency agencies, farmers, and researchers use seasonal forecasts to prepare for possible changes. Early warnings help reduce risk and improve resilience before extreme weather arrives. Despite decades of research, Earth's climate remains an extraordinarily complex system. Every El Niño event is different, shaped by countless interactions between the ocean, the atmosphere, and the changing planet itself. What makes El Niño so remarkable is not only its immense power, but also the reminder that every part of Earth's climate is connected. A change that begins in the tropical Pacific can eventually influence weather thousands of kilometers away. As technology continues to advance, new satellites, autonomous ocean sensors, artificial intelligence, and increasingly powerful climate models are helping scientists understand our planet with greater precision than ever before. Whether the coming months bring stronger El Niño conditions, gradual weakening, or a transition into another climate phase, one fact remains unchanged: careful observation, scientific research, and international cooperation remain our greatest tools for understanding Earth's future. Because beneath the waves of the Pacific Ocean lies one of the greatest forces shaping life on our planet. And as long as the oceans continue to move, the story of El Niño will continue to unfold.